and society important for research. So formula
No sound.
No
Rossi.
sound, Ross.
Oh, okay, okay, all right. Okay, is it better now?
Nope.
Oh, okay, all right. That's not better. Yeah. Okay. Mic is not picking up.
Tá dando retorno.
Yeah, I'm comfortable.
Como é que fala em inglês? Tá dando
Okay.
retorno?
Hello. Am I audible now?
Very weak.
Very weak. Okay. Hello. Am I audible now?
That's good now.
More or less.
Almost.
Is it better now?
Almost good.
Almost.
Okay. Now is it better? Is it better now?
Yeah, there is a noise in the background.
Yes.
Okay. Yeah. Sorry, I'm not being so audible on Zoom. So.
Nope.
Nope.
No sound. Nope.
Rasi can't hear.
Hello?
No, it's okay.
Probably it's not working. It's just taking a lot of time.
Yeah, audible.
You can record it
Now
and
it's
we can
audible.
share it out.
Okay,
Yeah.
okay.
No need.
Okay. Okay. So
Yeah,
yes. So I'm not audible on Zoom, I'm guessing. So okay. Okay. Okay.
It's okay. It's okay now.
Oh, it's okay now. Oh, great. Thanks. Thank you. Okay, I cannot see you all, but I really appreciate all those who are here on Zoom. Okay, I can't even see myself over here. Okay. Am I visible on Zoom? Okay. I'll just continue. I'll just begin my presentation now that I'm visible. At least something is working. Okay. First of all, okay. Thank you, everyone, and thank you all those on Zoom for attending my seminar titled "Why is the relationship between mathematics, education, and society important for research?" Okay. Is my presentation available on Zoom? I hope it is. If not, there will be a recording and that will be shared. Okay, I'll just directly begin as short because of lack of time and there's a bus waiting. Okay, so mathematics is hard has been a universal refrain amongst school children and often their parents for as long as we recall. But why do so many children dislike mathematics? Is it the way mathematics is taught? Because mathematics teachers follow the rote learning approach instead of making sure students understand basic concepts? Why are students from marginalized backgrounds or identities disproportionately lagging behind in and excluded from mathematics knowledge production? Or is mathematics really not for everybody? Okay. In this talk, I draw from my PhD research with visually challenged students to highlight the importance of taking into account social factors in mathematics education research to effectively address the challenges posed by STEM education and to work towards a world where mathematics really is for everybody. Okay. So my PhD thesis titled Exploring Implications of the Social Model of Disability for Mathematics Education was based on a case study of a learning center for visually challenged school children from socially marginalized communities in Mumbai, where I volunteered as a teacher for mathematics and music for over a period of 6 years. Part of my volunteer work involved tutoring students mathematics, especially when their exams were coming up. I share one incident or one particular teaching episode with one of my students. His name is Faizan. So his exam was in the next day. This was in 2013. He was in the 9th standard. His exam was in the next day. And one of the topics was related to parallel lines and perpendicular lines, among other topics. So, just a minute. Okay. So here in the textbook, I came across this particular scene. So there is a description of parallel lines and parallel planes. So now here, I'll just focus on the parallel planes. It says two non-intersecting planes are said to be parallel. In figure 1.14, planes are ABCD and EFGH are parallel planes. Write the remaining pair of parallel planes. Now, when it comes to the fact that we are teaching students who are visually challenged, now, so they can obviously not see these images directly, so it has to be made perceptible in some way. With regard to parallel lines, for example, we could use with regard to parallel lines, we could use something called as Wiki Sticks. They are basically sticky strings that you stick to a flat, clean surface in order to make diagrams perceptible. So with regard to these images which are broadly on a 2D space, these ideas could be communicated. But when we come to say a 3D cube, this really could not be communicated to a student with a blind student. So like for example, if you try to draw a cube on a flat clean surface, it basically looks like some sort of a hexagon with some points connected. So it really does not convey the information. Of course, we can use a block, but at that moment we don't have a block ready. But what I found interesting was around that time I was engaging with this with the Tower of Hanoi puzzle. Now the Tower of and what does this got to do? I'll explain what I'm saying. So now because Oh yeah. Okay. Right. So this is a Tower of Hanoi puzzle, and I'll tell you what has this got to do with the cube. So now the Tower of Hanoi puzzle is a puzzle which involves having a set of discs on 3 pins with the aim, and the aim of this puzzle is to get all the pins onto another all the discs onto another pin, subject to certain rules that a small pin can only move on top of a larger disk. A small disk can only move on top of a larger disk. So right now there are around 6. Let's just stick with say 3, for example. So to solve the Tower of Hanoi puzzle, you have to move like this one, and then you move the second one here because second one cannot come on top of this, and then now here you move this first one again. You move the third one this side. You move this one here. You can move this here, and then the puzzle is solved. Now, because I come from a computational mathematics background, and anyone who has done computer science and programming and algorithms, so they would have come across, modeling the solution of a Tower of Hanoi puzzle. So, and one particular model of solving the Tower of Hanoi involves tracing out a Hamilton circuit of an n-dimensional hypercube. So what I mean by that is when you say an n-dimensional hypercube, it basically refers to a cube in a generalized dimensional sense. So for example, so in order to model the solution of a Tower of Hanoi cube, you need to have a conceptualization of a higher dimensional cube. And that conceptualization will not depend upon, say, visual perception, because you have to ultimately communicate a model with a computer. So how does a computer, I mean, how do you construct an n-dimensional hypercube? Is algorithmically you do it by first constructing a n-1 dimensional hypercube. Then you draw that again and you connect the corresponding vertices. And then in that, so for example, if you have a two-dimensional hypercube, that's a square, and you draw the two-dimensional hypercube again a unit direction away from the square again, and you connect the corresponding vertices, you get a cube. For example, so if this is a square, I mean, just look at one plane. Now this is one square, then you draw another square on top, which is basically you construct another one, and then you connect the corresponding vertices. You go from a two-dimensional cube to a three-dimensional cube. And similarly, from now, how do you construct a two-dimensional cube? Because the computer will ask you how do you do that. So then, you say, okay, you first draw one-dimensional hypercube, which is a unit segment, draw another one-dimensional hypercube, which is a unit segment, and connect the corresponding vertices, and you get a square from a segment. Of course, then the computer asks, okay, now how do I construct a one-dimensional hypercube? You say, okay, construct a zero-dimensional hypercube, which by definition is just a point. So then you have, okay, so now you have a zero-dimensional cube, draw another one, you connect it. Now, the thing is through this approach, by constructing a 3D image using a 2D image, by tracing lines in the palm, I could communicate this to a student. Now, with regard to the why am I talking about the Tower of Hanoi? I'm talking about that because when you solve a Tower of Hanoi puzzle using the by tracing out a Hamilton circuit in n-dimensional hyperspace, n-dimensional space, then we see that the way you construct the Hamilton circuit. Okay, so I'll explain what is a Hamilton circuit. So a Hamilton circuit refers to a graph. Okay, so a Hamilton circuit basically, I'll explain this one. So a Hamilton circuit refers to a graph in which you connect, which has some vertices, in which you trace out, connect all the vertices without crossing over, and so that each point is reached only once. So, for example, if you have a square, if you have a square, for example, and these are the four vertices, 1, 2, 3, 4. A Hamilton circuit can be trace out these three over here. So you've reached all the three of them. Yeah, it's a path. Yeah, it's a connected path that connects all the vertices exactly where each vertex is reached at exactly once. Now, okay, coming back to the question, why am I talking about the Tower of Hanoi? So when you want to trace out a Hamilton circuit of a say one-dimensional hypercube, which is a unit segment, then you start from a point over here, let's say at a point at the origin, and you move along the x-axis, for example, and that's it. You've done it. So now, and if you want to trace out a two-dimensional hypercube, first you move along the x-axis, you move along the y-axis, and you move along the x-axis again. If you want to trace out the Hamilton circuit of a three-dimensional hypercube, then what you do? So instead of referring to these axes as x, y, z, because I would want to move on further, I'll refer to them as 1, 2, 3, 4. So when it comes to one-dimensional space, I say I draw one, and that's it. The solution, I've traced out the Hamilton circuit. When I want to do it in two dimensions, I do 1, 2, 1. And this meaning that I moved along the one-dimensional axis, I move 2 and move 1 again. And when I want to do it in 3 dimensions, I move 1, 2, 1, then I move in along the third dimension 3. So it's 1, 2, 1, 3, and then 1, 2, 1 again. Now, if you it is just connecting the particles. It doesn't have to. So a Hamilton circuit just involves tracing a connected path where you don't have to go back to the original. And I'll tell you what is the significance of defining it in this way. So, for example, if you, like I said, to trace out a one-dimensional hypercube, all you have to do is just move along the x-axis or move along the axis number 1. So, and if you move just 1, it gets solved. Now, this is a trivial example. But in maths, we generally start with a trivial example. Now, if you have a Tower of Hanoi with 2, and if you keep in mind that you have a two-dimensional hypercube, then the Hamilton circuit will involve moving along the first dimension to second dimension and along the first dimension again. So it is you move 1, you move 2, and you move 1 again. In the same way, if you have now if you have 3, now the solution would be the solution of the Hamilton circuit. I mean, the way of tracing out the Hamilton circuit would be 1, 2, 1, 3, 1, 2, 1. Now, if you look at the Tower of Hanoi, to solve this, first you move. This is number 1. The first is 1, 2, 1, 3, 1, 2, and 1. Okay. So now, without really having to imagine or maybe to look at a cube, we can really guess. You can really analyze that particular cube. So, okay, just for completeness sake, if I have 4 over here, then the solution, I think you can easily find out it is 1, 2, 1, 3, 1, 2, 1, 4, 1, 2, 1, 3, 1, 2, 1. So 1, 2, 1, 3, and this will be 1, 2, 1 again. 4 for lack of time, and 1, 2, 1, 3, 1, 2, 1. I'm just there's a bus waiting. So okay, so you get the point. So basically, in short, in case you want to solve a model, I mean, I was basically looking at a Tower of Hanoi because I come from a computational mathematics background, and I wanted to develop some activities for teachers and college students to basically inculcate algorithmic thinking. And I came across a conceptualization of a cube which did not depend upon visualization. And I checked with Faizan if this works. And when I asked him this question, then I asked him, okay, can you trace out a cube on my palm? And he said, okay, first I'll trace out a 2-dimensional hypercube, which is a square. Next to it, I'll draw another one. I'll join the corresponding points. And I asked him, okay, now if can you identify which are the parallel lines and parallel planes? And he could well identify. And by conceptualizing a cube, with the help of a Hamilton circuit, we also find additional patterns over here, in the sense that the parallel lines and parallel planes have a particular kind of pattern. Like for example, in this case, you have the parallel lines are 1, 2, 3, 4, 5, 6, and 7, 8 are parallel. And also you can observe certain planes. Of course, there is certain complications. It's doesn't directly follow. But the point is that this particular concept could be communicated. However, now, of course, I'm guessing in this context, the student was in the 9th standard, so a lot of questions do come about. So, but basically, through a different mathematical approach, a concept could be made accessible to a visually challenged student, and furthermore, it facilitated a richer mathematical interaction. But now this raises many questions. But can every mathematical concept be made accessible through a different form of mathematization? And another question which is related is the underrepresentation of visually challenged mathematics learners and mathematicians merely a pedagogical problem? So I'm hinting that it's probably not just that. In order to address this, I share another episode of from my research work involving another student. Her name is Rani. So Rani, I was tutoring her for also oncoming exams, and in the midst of discussing, she had digressed from what was being discussed, and she was speaking about being discriminated against in her school. So Rani had just recently shifted to the 9th standard, to a different school, and in the 9th standard, and she was saying that during her exams, she was made to sit separately, where there was broken benches, the fan was not working, and the teacher told her that her writer was a source of distraction for the other students. However, Rani said, my school before this was very good. I did not at all feel any different. And even another student from the study center, they cooperated. But they said, but this private school, they discriminate very much. They keep me separate and so on. So what is interesting is that both the schools were not particularly equipped to handle students with disabilities, but in only one particular education and learning environment, she was facing disablement from learning. She was disabled from learning mathematics only in one particular setup, but not in the other. So this indicated that Rani's exclusion was not a consequence of disability, but rather the cause of a disablement. So generally, the popular perception of the relationship between exclusion of visually challenged students and their disability, the relation is seen as, okay, a student acquires a physical impairment and therefore they are excluded from mathematics learning. But however, if you actually look into it, the relation is the other way around. I mean, they are disabled from learning mathematics precisely through their exclusion. So the exclusion is the cause of their disablement from mathematics learning. And I'm stressing on mathematics learning because if I mean, as maths educationists, when we educators, when we really want to address the question of disability, I mean, we have to address it in concrete terms. So when you say, so that's why I'm stressing on the disablement for mathematics learning. That's an outcome of the exclusion, not the cause of it. Okay, sorry. Okay. So, and however, there are many more factors. Moreover, in Rani's new semi-private school, she needed to pay fees. The school's classroom were overcrowded. She and her writer were made to sit on a broken bench under a non-functional fan during exams. So, our school was evidently under-financed. And so, this question is, okay, now why is that? This question I will not really address right now. And I will go on to some mathematics sessions, mathematics camps that we are organized at the study center as part of my data collection. So this is a image, one of the typical image of mathematics discussions. The student who on the bottom right, he's Faizan. So at this particular time, there was fewer students. I'll not go into detail about the technical aspects of the mathematical discourse that went through, but what I did observe that in the learning environment, there was a culture of empathy and cooperation among students. The older students ensured no other student was left behind. Students often communicated by holding each other's hand and tracing out lines on their palm to communicate. So Rani would often clarify my points and questions in Marathi to her colleagues. Another student, Monica, diagnosed with, it's a problematic term, but that's a diagnosis, it's called mental retardation, who seemed to prefer to be uninvolved in discussions, often spoke to fellow mathematics education researcher, who in turn put forward Monica's views. The students often ignored my attempts to proceed with the topic if they saw that a peer was unable to catch up. They saw to it that no one was excluded in any way. So yeah, by ensuring that an exclusion wasn't happening, they ensured that their colleagues were not disabled from learning maths. With regard to the content, I mean, so we did reach a consensus on the ways of determining whether a number is divisible by 2, 3, 4, 5, 6, 7, actually 9, 10, 11, and also certain combinations like 15 and so on. The test for divisibility of 9 proved to be particularly easy since the proof followed directly from the standard technique of calculating using the abacus, which the students were familiar with. So on the abacus, 9 is treated as 10 minus 1. I mean, if I have to translate it in this way. Therefore, when 9 is added to a number, a bead in the tens place is moved towards a partition. I'll show you the structure for abacus to clarify. And a bead in the units place is moved in the home position. Thus, the total number of beads displayed, which equals to the sum of the digits of the number, remains invariant when 9 is added to it. So, for example, when you have an abacus, so it's an abacus displaying number 9, and next to it is an abacus to which 9 has been added. So, when 9 is added, you move 1 to the home position, and you move 1 upwards. So, you move 1 to the tens place, you move up, and units place, you move down. So, the total number, which is so the top beads represent 5 and the bottom beads represent 1 each. So the total number of say digits will be on one hand will be 1, and this is 5, 6, 7, 8. So it's 9. So okay, earlier you have 9 over there, but when you add 9 to it, you basically move 1 up and move 1 down. So the total remains the same. So in a similar way, when you have say a bigger number like say 2304, you add 9 to it, you get 2313. Where the total number still remains 9. Of course, there are some complications when what about 99 plus 9? Those we also, but it kind of reduces that down to the number of beats, which ultimately they did understand the concept. Which was anyway. So at another mathematics camp at the center held some months later, I decided to revise and move forward. And on raising the question of the number 0, like the students were arguing that it is both an even and an odd number. I don't want to impose what I call the correct answer. So the reason that when you have say according to the textbook, the definition of an even number is that a number when you divide among 2, nothing remains. So for example, the student was saying that in the case of say ice creams, if you have no ice creams and you divide no ice creams among 2 people, nothing remains. However, so in that case, it is an even number. However, if you don't have any ice creams to begin with, you cannot really divide ice creams among 2 people. If I promise you all ice creams and I say 0, I'm not really dividing ice creams among you all. So in that case, 0 cannot be divided by 2, and therefore it is an odd number. Obviously, I was uncomfortable with this. But later on, the student, same Faizan, he pointed out, and then the other students took on this argument further, that he observed that there's a pattern among odd and even numbers, that odd plus or minus odd is even, even plus or minus even is odd. And so 0 has the properties of even number, so 0 is therefore an even number. It's best categorized, sorry, he said it is best categorized as an even number. But then on another occasion, he also pointed out that, but actually 0 has another special property. It's a special even number. Unlike other even numbers, if you keep dividing 0 by 2, you don't arrive at an odd number. So for example, if you take a number like 12, now that's an even number. You divide it by 2, you get 6, divided by 2, you get 3, that's an odd number. But so you have a certain properties of even number, which is not shared by 0, as was pointed out by Faiz and then taken on by other students. And so of course I was a little bit uncomfortable at that position, because I obviously did not want them to go with this particular understanding, and the students did recognize that I was a little bit shaken by this, and they kind of reassured me, saying that don't worry, for the exams we will understand that 0 is even, but actually it is a special number. On another occasion, when we were discussing about, say, odd and even numbers in the context of negative numbers, and I asked, okay, like what about number of -4, is that odd or even? And then the discourse went on the lines that, see, when we had seen in the case of, say, ice creams, when you had like 4 ice creams, you can divide, वो हम 2 समान हिस्से में बांट सकते हैं, इसलिए उसको नाम सम संख्या बताया, means we can evenly divide it in 2, therefore we gave the name even numbers, and in other case you gave the name odd numbers. So but in the case of negative numbers, you can't have negative ice creams. So something might have happened because of which these negative numbers came about, and only once we know that can we say whether it is even or odd numbers. Okay, what do I do then? So anyway, I thought, okay, let's try to look out for situations where negative numbers are necessary. So then so one student, his name is Prasad, he said out, in the parking lot, there was in the basement, there was -1, -2 shown in the lift. So then, yeah, the discussion went in that line that, okay, so when they had gone, so basically someone had taken them to a mall where the upper basement and lower basement had numbers -1 and -2. So they said, something like that might have happened, from which negative numbers might have come about. Although, but then the discourse went, but negative numbers predate malls. Anyway, there was an interesting discussion that ensued from there. But then finally, it was agreed upon that there is some sort of a pattern over there, that when you take a positive number and you keep on, say, going downwards, then you come across, you have a pattern of even, odd, even, odd, even, odd. And there, if you categorize 0 as even and -2 and -4 as even, then this pattern remains. So then -4 is best categorized as a even number. So that was very much interesting observation. So these practices, which were very much kind of, which I found to be very authentic, and which were very much related to the process of mathematics, I referred to as authentic mathematization. So for example, discussing mathematical ideas like a hypercube, etc., by tracing out on a peer's or teacher's palm, basing concepts of negative numbers on the historical basis, or rather than looking at examples in the book, proving the divisibility of 9 on the abacus rather than on the black whiteboard, and so on. So I define authentic mathematization as mathematics learning connected to material practices without the expectation of arriving at a predetermined correct answer. Now, in the context of students with disabilities, I found that authentic mathematization, which is an outcome of collective learning practices, foster not only inclusive but also mathematically richer learning. However, like, although in the in my 5th year of my PhD, I tried to say that, okay, this is the broad thesis. But when I was in the 6th year, then my students one of my students required a writer for an entrance exam for a job, and so there, when I went over there, did I see the kind of the limitation? How does inclusive learning and inclusive mathematics play outside the classroom? Like, because if our aim is to help our students learn, we also need to figure out what happens to them once they leave the learning environment. So the student's name is Sunny. So he was in a 12th standard, and he was giving an entrance exam for a job for a subordinate post in the railways. There were thousands of candidates for 100 vacancies in the physically handicapped quota. The examination for the job had 4 sections: logical reasoning, science, general knowledge, and mathematics. Now, keep in mind that the job required no knowledge of mathematics whatsoever. However, it featured unnecessarily long mathematics questions. And these were like impossible for even me to solve with my eyes closed, even after reading the question. So, so whoever framed these questions either wanted to explicitly sift out, visually challenged students, or maybe they were just not concerned because ultimately you just want a handful of students and you don't care what happens, who among the rest are excluded. And also I observed that cheating was quite prevalent and perhaps expected. Cheating in the sense of there were many cases where writers were actually writing for the students, and when I asked to my other student who also had gone through this process, she also was saying in a very agitated manner that that cheating is quite prevalent, and this actually affects the way blind people are seen. So, for example, even if they do attain a decent employment or decent position, they are seen with suspicion because people think that they probably cheated. And on probing it further, I found that there's actually a market for professional cheaters. Basically, there are people whom you can find, you can give them a few lakhs of rupees and they'll guarantee you success in this in an entrance exam. They are just suitably qualified to not be overqualified, but so so when we look about these limits of inclusion, we see that there is like more to the problem of inclusion than just pedagogy. So with regard to the economic aspect of disablement, the World Bank's discourse on education for all emphasized the inclusion of the disabled community. But on the other hand, the IMF World Bank's imposition of structural adjustment reforms in India led to a state withdrawal from the service sector, which made it increasingly difficult for people with disabilities to access education, healthcare, employment, etc. In fact, even the NCF 2005, as Jesse was mentioned, had said about getting students with disabilities into regular classrooms rather than special education classrooms. But now the thing is, okay, if you send them to special education classroom, there's a problem because you kind of construct them as you otherize them. But when you come to the mainstream, the main classroom, then again there's a challenge of there's a challenge of being othered into the classroom. And furthermore, so the problem is not just, so how do you come out of this dilemma? So, but the question is, why is it that in regular classroom students are disabled in the first place? And we see that there is a political economic dimension to it. So the Nobel Prize winning World Bank economist Joseph Stiglitz had admitted that as families in many developing countries have to pay for their children's education under so-called cost recovery programs imposed by the International Monetary Fund, the IMF, their parents make the painful choice not to send their daughters to school. So therefore, especially in the context of third world countries which have adopted neoliberal reforms, exclusion and disablement of visually challenged mathematics learners cannot be understood in isolation from the interconnections between competition, examinations, failure, unemployment, rising school fees, underfunding of and the deteriorating conditions of public schools, overcrowded classrooms amidst a scarcity of jobs for qualified teachers, increased privatizations of schools and internationalization of profit, etc., that characterize neoliberal capitalism. So coming back to the question we started with. So why do children often dislike mathematics? Often the standard response is, well, because the problem lies in teaching. If you teach them well, they will like mathematics. But then, and often you say that, okay, teachers follow the rote learning approach. But then the question arises, how much agency do mathematics teachers have to practice meaningful and innovative teaching when there is the pressure of not only completing the syllabus, but ensuring that the students pass their exams and find meaningful employment? And what is the effect of socio-political and economic socio-economic factors, for example, the job market, high-stakes entrance exams, in shaping the nature and practice of school mathematics? So I feel that these are important questions to be addressed because I'll cite Stephen Jay Gould over here. I think this is important because we are losing out on a lot of really potentially great mathematicians. As Stephen Jay Gould said, I am somehow less interested in the weight and convolutions of Einstein's brain than in the near certainty that people of equal talent have lived and died in cotton fields and sweatshops. And we have seen also a lot of students who are being excluded away, who have been pushed away. So Albert Einstein is one of my favorite mathematicians, actually. And this is one of his quote that he said, with which I will end. So he said, technological progress frequently results in more unemployment rather than in an easing of the burden of work for all. Unlimited competition leads to a huge waste of labor, and to that crippling of the social consciousness of individuals. This crippling of individuals I consider the worst evil of capitalism. Our whole educational system suffers from this evil. An exaggerated competitive attitude is inculcated into the student who is trained to worship acquisitive success as a preparation for his future career. And that's the end of my talk. Thank you so much. Okay. So it's 4:30 now. Any questions? Yeah, am I on Zoom? Okay, yeah, sorry.
Yeah, okay.
Yeah.
No, some of your slides are very general, so I just mathematics education may as well apply for this one.
Okay. Yeah, that is true. But can you like give a specific example? Like, okay. Yeah. Oh, yeah. Yeah. Yeah, that's true. So my focus was on mathematics education, but there's a lot of discourse on because, like, for example, my students, when they were studying for maths exams. So now the thing is, although this applies across disciplines, so therefore that is precisely why when you're talking in the context of mathematics education, you cannot avoid this particular question. So for example, in the field of mathematics education research, there's a lot of focus on, say, inclusive mathematics learning. So, but now the thing is, okay, if you're talking about inclusive mathematics learning, the emphasis has largely been on the pedagogical aspect, not on teaching aids. Now, these are extremely important, but of course, if you want to address the question about why are say visually challenged students underrepresented in the mathematics classroom, now you can now of course, so now you cannot avoid the you have to take into account the factor that that mathematics students are also students of education, and now education is being underfinanced. So although this applies to all, and so but now this should not be a justification to not take into account that factor when you're focusing on mathematics learning. So this is one aspect of mathematics, but there are many other aspects of mathematics which I found to be extremely where mathematics specifically plays a role. So for example, in the context of of entrance exams, so you have a lot of so for example, now you can say that these structural adjustment reforms imposed by the IMF, now these impact say history and geography, which are extremely important subjects, but when there is a job opening, you don't have that much of, say, history and geography. I mean, there is general knowledge, but mathematics plays a crucial role over there. And mathematics also, because among other things, like if someone fails in a maths exam, or rather if there's a person who is unemployed and he has tried to get an employment, and then you say, okay, why is this person unemployed? Rather than responding by saying that we are living in an unemployment crisis, they're saying, oh, you failed in your maths section. Now you're saying, but and also there's a discourse on mathematics is very neutral, it's very objective, which has a huge truth to it. However, this is conflated to when it's put in practice in certain forms of distorted practices, it is used to justify the unemployment of people by individualizing the causes of their unemployment. We can discuss this further. Yeah.
I mean, I was just thinking that mathematics has the reputation of being the gatekeeper.
Yeah.
But we routinely used in examinations and all the things to eliminate.
Yeah.
So first round of testing would be to use math and eliminate a whole lot of people, and the next round you have exam. So that's, I think, one reason. No other subject somehow functions like that. One doesn't probably use science to exclude. Why does one use math? Because one could actually take even primary school mathematics or middle school mathematics, put it in the exam.
Yeah.
So that you can eliminate using that.
Yeah.
What is the way out?
Out
of this prediction?
That's a good question. But so one thing is, firstly, I think it's important to not just describe the situation, but also provide an analysis of this particular situation. So with regard to my work particularly, so like as a form of the implications of my study, so I did say that so there are various aspects to this way out. So the thing is, okay, when you say what is the way out, I mean, of course, narrow individual solutions cannot work. However, but at the same, yeah. So, however, this doesn't mean that you follow a very pragmatic approach, because these lead to more, more kind of contradictions over here. With regard to, yeah. So when you say what is the way out, I mean there are various. Okay. So for example, yeah. So it might seem obvious that one of the way out is to teach the students and improve the way we teach mathematics to our students. But then, however, when that happens, for example, my students, they are really good in mathematics, but now they are unemployed, at least from mathematics, and their unemployment is pretty much used in to justify the wages of employed people. So, for example, when I was working in a private industry, it had the board meetings would constantly discuss on how to reduce labor costs, and and labor cost reduction meaning not to employ people, not to improve their working conditions. And if anyone had a problem, it was like there's always somebody with equal capability who can replace you and who's willing to work for lesser salary and under more hazardous working conditions. I used to work in a hospital. So yeah, the way out, yeah, that's actually a very a challenge. But however, it does not. But of course, the way outs proposed hitherto have always not addressed certain contradictions of the kind that cannot be that arise from the economic aspect of disablement and exclusion. So one way out would be probably to reorganize the entire economic structure, which is built upon producing unemployment, which is built upon certain contradictions.
This applies to any kind of education.
It does apply to any kinds of education. However, when but in the context of mathematics specifically, as Jashi was mentioning, it plays a very central role, say at various levels, say within say a capitalist supply chain. So so for example, I used to work in a hospital, and there was a lot of mathematics I would do, but at a very low level, because I used to repair equipment. So I would change resistors here and there if a particular resistor blew up in a particular circuit. But there was a mathematics in a microprocessor. So there was kind of like a meritocratic division of labor which was happening. Some people who at some position doing some mathematics, some people at the bottom who doing some other kind of mathematics. So this particular larger structure, economic structure, that in which mathematics plays a role, this is what I found to be one of the underlying reasons behind the marginalized position of people with disabilities. And so my argument is, in one way, the larger argument is, if you want to way out, we need a way out of this particular economic structure. And the way to do that is to basically address the specific contradictions that arise out of, say, a capitalist mode of production. Thank you.
Yeah.
Thank you. Yeah, I can hear you.
So thank you for this very interesting topic. So one thing you mentioned here that you also teach music.
Yeah.
To the students. So that's the one to be.
Yeah, so yeah, that's true. In fact, my PhD kind of evolved out of the volunteer work I was doing. So we had visited the study center for blind students more out of curiosity, and then the school suggested that they wanted some music. They wanted someone to engage us children with music and some recreational activities. And after that, we also would do these activities related to science and maths, and then got more involved with their school work and with larger extracurricular work as well. Yeah. Yeah. With regard to music, actually, I did not really teach note reading, but within music education, the notes, I mean, there is a lot of braille and all which is available for blind musicians. However, of course, my point is not merely that to teach music also you need to use braille, because very often not all students even have perceptible ways of reading. So even when it comes to music also, I would say it is also kind of more like a social collective practice, just like how mathematics is. So the thing is, when it comes to say mathematics learning, very often certain discourses say that, well, mathematics, like the visual aspect of mathematics tends to be very ableist and so on. But my argument is that, well, because many of us can see, that's why our students can learn. many of us can see. That's why a student can learn music as well. I mean, it's kind of more like a social practice. There are braille approaches for learning music, but that is not the approach I had used.
Actually, both have the creativity, music and mathematics.
Yes, that's true.
So mathematics also, you start with certain axioms, you
Ah.
have a question from the axioms,
Mhm.
then develop definitions and theorems.
Mhm.
Like in algebra, you study them up to isomorphism.
Yeah.
In topology, study geometry structure till they remain invariant. And the certain
Yeah.
isomorphism.
Yeah.
So both
Music.
mathematics, both have creative.
Yeah, that's true.
That's how it's abstract.
Yeah, thank you. And also, and furthermore, there's also a scope for new compositions, for example. Yeah, because like mathematics is not merely, it's not like predetermined. When you start with axioms, I mean, we do not know where we're going to end. Hmm? Yeah, you begin with that. Yeah, so you basically just say that your claim is truth insofar as they're consistent. Yeah. So we do say that rather than say talk about truth and falsity, we say whether it's consistent with axioms or whether whether they are not consistent, contradictory to the axioms.
Right?
Oh, yeah.
I just want to push you.
Oh yes, please.
See, you said, I mean, one way to read what you said would be that these blind kids are rather goody. They're kind of very helpful and nice and all that. Unlike us, we are sighted. We are not really willing to check. No, I mean that seems like how do you?
Yeah,
I mean, how will you actually?
Yeah.
I mean.
Yeah, so that is not the. I mean, if I did
I know
come
that's
across,
not what
yeah,
you meant. I mean,
yeah.
I really want you to actually.
Oh yeah. Anyway, thanks for pointing out, because
go.
thanks for pointing this out, because I did not intend to glorify this classroom, because of course in any classroom environment there will always be some students who are competitive, or in certain situations where they would want to be competitive. But by and large, like even though there were a few students who might have been more competitive, they were also very helpful. So there was an aspect of cooperation. Of course, there was an aspect of competition as well, but it's the cooperative aspect which kind of facilitated inclusive learning and facilitated a more a richer mathematical discourse among them.
Connected to, say, for example, how gender.
Yeah.
Again, this is always said that
Yeah.
boys are competitive, girls are cooperative.
Yeah. Yeah.
Do you see that? Do you see? I mean, would you think that there will be some kind of a connection?
There is broadly a connection. In fact, just about 2 weeks back, I had shared some. I did a workshop with pre-service school teachers in HBCSE. I shared a couple of papers, but the paper that particularly captivated all the students, even those who did not read that paper, was a paper which basically was of this my friend Saurav Khanna, who spoke about a sociological aspect of mathematics learning. So he did anthropological study of a well-resourced school classroom, and he observed that specifically the boys in the front were highly competitive, and the students at the back, predominantly girls and also students from certain marginalized communities, who were sitting at the back, and they were largely ignored by the teachers, and there was some sort of a cooperation and say competition. So yeah, so generally, and of course he had attributed this to the fact that the school was located in a very posh locality, and of course so the students and the teachers are largely embedded within the larger structure of that particular locality, where there is a competition across schools, so where competition is seen as a norm. But of course some students, they probably cannot afford to compete, or they see the limits of they don't want to compete, and they are more cooperative. And so in this regard, I mean, there might be by and large a gender dimension, but of course in the question arises, what exactly is gender in the sense of whether it is a reification of something or whether it's a social construct. Because when it comes to the question of disablement, I talk about it in specific context of mathematics, and so when it plays out in a certain way, then I say, okay, these conditions disable students, and furthermore it reifies their exclusion as disability. So in the case of gender also, like now, okay, so when there is a gender dimension, why is it that it plays out in certain ways, so that what it appears to be that the students who are highly competitive tend to be more boys? How does this play about? So I would agree with you, but we'll have to really look into like, what are the underlying causes behind?
Yeah. Could you ask a question from the two participants?
Which one?
Two participants. They are
Oh yes. Oh yeah. Yes. Okay. Where are the?
just ask them.
Yes. Okay. 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 Zoom participants.
Because I do not have time.
Okay. Okay. There's a chat over here. Okay. Is anyone on Zoom would like to share some comments or questions on the chat? I hope I don't know. Am I even audible on Zoom? I'm not sure.
Yeah. Are there any more questions?
Yeah.
So the question came to my mind about when you talk about authentic mathematician
Yeah.
and give the example of negative numbers about how
Yeah.
children understood it.
Yeah.
Okay, the concept of a basement.
Yeah.
For somebody, let's say,
Yeah.
who is blind by birth,
Yeah.
obviously. So, but how would you, and you talk about connecting it to material practices, but how would you do it for a lot of concepts in mathematics which are way too abstract? Like, I mean,
Yeah.
for example, irrational numbers or all kinds
Yeah.
of, so
Yeah.
what about that? Then how does authentic mathematician?
Yeah. So so my argument is not just that, just take any mathematics in order to make mathematics more accessible, it has to be made more perceptible. However, like, because for example, I was also talking about teaching a n-dimensional hypercube and spoke about a 4-dimensional hypercube, and I said that even this is a form of a material practice, because a 4-dimensional hypercube is as probably imperceptible as, say, an irrational number, because we don't kind of observe irrational number. I mean, we observe circles, so we can observe pi to some extent, but we don't really observe irrational numbers, and neither do we observe 4-dimensional or n-dimensional spaces. But however, like, the argument which I am making is also largely an argument which is also being made in among philosophers of mathematics, who say that whatever, even the highly non-perceptible forms of mathematics can be, I would not say reduced, for example, but can be derived from something more basic. So for example, you have something called as piano axioms, by which even complex numbers are defined in a way, because when you say, okay, so because it's not just about making them perceptible, because if I talk about complex numbers, a question, okay, what is the definition of a complex number? Now, okay, I can say square root of -1, but -1 cannot be made a square root, but then how do you show it mathematically? So for specifically in the case of irrational numbers, one particular definition is that an irrational number is basically, or any real number is a limit of a Cauchy sequence. I hope that, okay. So a Cauchy sequence is a sequence of basically rational numbers, and the limit of that. We can discuss further. And a rational number is defined with the help of integers, and integers are defined with the help of natural numbers. And natural numbers are defined. But say this is from one particular tradition, which is referred to as piano axioms. So in the same way, like, so when I spoke about a 4-dimensional hypercube, I said, okay, if we started off with tracing out figures and tracing out something which is perceptible, and from there we observed a pattern which we extended to a higher dimension. So I'm not saying that, in order to teach, we need to get something, which is very perceptible directly. But I am saying, to some extent, you can start with that. You start with that, and from there we can, expand it we can extend it. Yeah. Oh, thanks. Okay.
Yeah, I also had a question.
Yeah.
How to teach a visually challenged abstract algebra, a group theory or something like that.
Yeah.
And the zeros concept.
Yeah.
And the odd events. So how to teach group theory, let's say. If you have any approach.
Yeah, actually, because my students were in school, but so if I had to answer a question, I would probably work with the student and like. Okay, someone is speaking from Zoom, I think. Yeah, so if I were to answer that, I mean, I've not really looked into this concretely, but if I were to answer this question, if I were to teach someone, I would have to maybe do a discussion, try to figure out what might be the best way, whether can teach with the help of a Rubik's Cube, or whether, because there are many activities which have been done. It's hard to define. In fact, even there's a lot of group theory in this, like, algebra 1-to-1. Anyway, but of course, I'm just thinking on this on the fly. I haven't analyzed this from a group theory perspective, and I might run into contradictions.
Yeah. Are there any more questions? On behalf of organizer, I thank all participants here, those are here, and those are attending from remote. And I also thank Professor Joyce for inviting you, and thank you.
Thank you so much.
As you notice that it's very new university, so
Mhm.
we are trying.
Hello, sir. Hello.
Okay. Someone is talking on Zoom, I think.
Sir, my name Panduranga.
Yeah, hi, Panduranga. Yeah, hi, I can hear you. Can you, you have some comment or question? Oh, sorry. Someone is simply on Zoom. Yeah.
Sir, in class, there is a Panduranga Dattatreya. He was disturbing.
Okay. Do you have a question or comment or okay?
Okay.
Okay.
He both are fuckers.
Sorry, we can't hear you on Zoom. I think we are ending the talk now. Oh, sorry. Thanks. Okay.
Waiting for you. Thank you.
Okay. Thank you all. Thank you so much.
Scammer. Anyone need iPhone 13 Pro Max available? Hello, Raman Sahora. Big fan. Big fan.